Hello everyone, Assalamu alaikum. Myself Nabil Shartas Khan, and then today I'm going to discuss about Task 4. I'm from Group 26. My group members are as follows on the left side. We are working on the project which is heart disease prediction using machine learning, and our Task 4 was about the first draft. And I'm going to discuss about the introduction, about the problem which is heart disease prediction and how we're going to tackle it. And then I'm going to discuss about some literature reviews, and the rest and the work plan will be discussed by my fellow teammates. So let's get started with it. Firstly, the introduction. We know about heart disease. It describes a lot of range of conditions that actually affects your heart. So diseases under heart disease includes like blood vessel diseases. You can see people are suffering from blood vessel diseases, or people are suffering from coronary artery diseases. Again, their rhythm of their heart sometimes is quite low and then quite high. This is some sort of heart disease. And then some are comes by born, or you get from inheritance, and some other things. These are some heart diseases. We must know that cardiovascular disease generally refers to the conditions that involve narrowed or blocked blood vessels that can lead to a heart attack. So basically, if you don't take care of these problems, we may encounter problems like heart attack, and then chest pain, angina, stroke, something like that, or some sort of other heart conditions will affect our heart muscles, valves and rhythms. It's also considered from a heart disease. So in this paper, we'll be using machine learning, and through machine learning, we're going to use three algorithms. So sorry for the slight pause. So there was some sort of issues. Okay, so we'll be using about four different algorithms to visualize the models, and then eventually we will evaluate all the models and predict which algorithm has the better score, and we will evaluate them. So the four algorithms we're going to use is a logistic regression, and then SVM or support vector machine model, and then KNN, on which the k's nearest neighbor, and the knife base. So these are the four algorithms we're going to use. So let's get started with the literature reviews. Okay, the first literature during about the literature reviews, we have found about 12 papers which are actually based on the studies in our sector. They also studied on the heart disease prediction. So first four will be discussed by me. So the first one, actually, the comparative study on heart disease prediction using machine learning algorithms, which was by Ramesh and Bhuvaneshwari and Jaishankar. It's mainly focused on comparing the performance of various machine learning algorithms for the heart disease, just like us. So yeah, the authors provide a comprehensive review of the various algorithms used in the studies and their respective accuracies. In the second paper, it's about predicting heart disease using machine learning algorithms, a systematic review. It was by Al-Ghumadi, Al-Khalaf, Al-Muhaideb. It discusses various studies that have used machine learning algorithms for predicting heart disease. They used decision trees, neural networks, support vector machines, and random forest. They provided a summary of the algorithms used in each study and corresponding accuracies they achieved. Other than that, they also mentioned the issues as the data imbalance, overfitting, and interpretability of the models. Okay, so the third one is a heart disease prediction system using machine learning techniques. It was by Ullah, Atik, and Hussein. It's a machine learning based on to predict to risk of heart disease using a data set which contains the patient's information. So they used like information like age, gender, blood pressure, cholesterol levels, and other medical parameters. They used algorithms like K nearest neighbor, decision tree, knife base, random forest, and SVM, the support vector machine models. And they found out that the SVM algorithm had the highest accuracy, which was about 87.5%, and random forest had the accuracy of about 85%. The fourth paper is about the hard disk prediction using ensemble machine learning techniques. It was by Abu Salah, Al Tamimi, and Al Azlan. It was aimed to develop a predictive model for heart disease using ensemble machine learning techniques, which will actually combine the multiple models to improve the accuracy and robustness of the prediction. They also use the informations like age, gender, blood pressure, cholesterol levels, and other medical parameters to train and evaluate different techniques. The techniques they used was about bagging, boosting, and stacking. They find out using this technique that stacking literally outperformed every other methods with the accuracy of 93.5%. So the rest of the presentation will be done by my friends. Thank you everyone for listening to me. Uh, Thank you.
Hello, I'm Obichet and I'm going to review the following four papers. First of all, the paper A Review of Machine Learning Techniques for Heart Disease Prediction by Ramesh Bhuvaneshwari and Joy Shankar provides a comprehensive review of various machine learning techniques that have been used for heart disease prediction. The authors reviewed several studies that employ machine learning algorithms such as decision trees, support vector machine, in KNN, NAIP-based random forest, and artificial neural networks for heart disease prediction. They found that these techniques achieved accuracy rates ranging from 70% to 98%. Moreover, the study identified that age, gender, blood pressure, cholesterol levels, and smoking habits were the most common predictors used in machine learning models for heart disease prediction. The authors also discussed the advantages and limitations of each machine learning technique, as well as the potential challenges in developing a robust and accurate model for heart disease prediction. Okay, now coming to the second research paper. The paper here, Heart Disease Prediction Using Decision Tree and NAIP-based classifier by Thiman, Agarwal, and Banshal, proposed a predictive model for heart disease using two machine learning algorithms, decision tree and NAIP-based classifier. The authors used a dataset containing patient information such as age, gender, blood pressure, etc., to evaluate the performance of two algorithms. They found the decision tree algorithms had a higher accuracy rate of 85.1% compared to the NAIP-based classifier, which achieved an accuracy of 82.5%. Moreover, the study identified the most significant predictors of heart disease, which included age, gender, chest pain type, blood pressure, etc. The authors concluded that the proposed machine learning-based system could be used as an effective tool for early diagnosis and prediction of heart disease, and can assist doctors in making informed decisions about about the treatment and management of patient with heart disease. Now coming to the third research paper, the paper here, heart disease prediction using support vector machine and artificial neural network by Hassan and Aljian proposed a predictive model for heart disease using two machine learning algorithms, support SVM and ANN. The authors used a dataset containing patient information such as different parameters and other medical parameters.
Hello, I'm Ron Bishash. I'm 2034-1023. Today I'm presenting the literature review of heart disease prediction using machine learning. The paper, A Machine Learning Approach for Heart Disease Prediction by J.P. Xu and S. Panda, proposed a predictive model for heart disease using machine learning algorithms. The author used a dataset containing patient information such as age, gender, blood pressure, cholesterol level, and medical parameters to train, evaluate performance of various machine learning algorithms, including decision tree, random forest, k-nearest neighbors KNN, and the sample vector machine SVM. And they found the SVM algorithm achieved the highest accuracy rate of 94.54% compared to the other algorithms. The heart disease prediction using the random forest algorithm by A.B. Beck and R.V. Krishnashankar aimed at develop a predictive model for heart disease using the random forest algorithm. They found that the algorithm achieved an accuracy rate of 92.07% predicting heart diseases. The author concluded that the random forest algorithm can be a useful tool in predicting heart diseases and can assist doctor in making information decision about the treatment and the management of patient with heart disease. Thirdly, we can say the paper heart disease prediction, Kenner's neighbor, and the decision tree algorithms by J. Core and R. Core aim to develop a predictive model for heart disease using a k-nearest neighbor, KNN, and decision tree algorithms. They found that the KNN algorithm achieved an accuracy rate of 86.89%, while the decision tree algorithms achieved with an accuracy rate of 80%, 32%. This predicting heart diseases. The author concluded that the KNN algorithm can be a useful tool in predicting heart disease and can assist doctors in making information decisions about the treatment and management of patients with the heart disease. And lastly, we can say the paper, A Hybrid Machine Learning Model for Heart Disease Prediction by S. Zhang and Y. Li and Y. Yan aimed to develop a hybrid machine learning model for heart disease prediction by combining several machine learning algorithms. They found that the hybrid model achieved an accuracy rate of 94.3% in predicting heart diseases. And the author concluded that the hybrid model can be useful tool in predicting heart disease and can assist doctor making informed decision about the treatment and management patient with heart diseases. Thank you.
Hello, I'm Shaya Sabrin, and this is our work plan for our project. Our workflow diagram starts with collecting the relevant data. The data is then cleaned and pre-processed to remove any missing or inconsistent values. Then we plan to convert categorical variables into numerical ones. Exploratory data analysis is conducted after that to gain insights into the data. Next, feature selection techniques are used to identify the most important features that are predictive of heart disease. Next, appropriate machine learning models are chosen. Here, we have selected to work with logistic regression, SVM, KNN, and naive Bayes algorithm. These models will be trained using the preprocessed data, and their performance is evaluated using cross-validation techniques. Then, the hyperparameters of the selected models are optimized to improve the performance of our project. Lastly, the performance of the different models is compared based on various evaluation metrics. Our selected models are then interpreted to gain insights into the factors that are driving the prediction of heart disease. The selected models are deployed in production environment, and its performance is monitored to ensure that it continues to provide accurate predictions over time. Feedback mechanisms are also incorporated to update the models as new data becomes available. So, this is how we are planning to work in our project. Here, the workflow diagram emphasizes the iterative nature of the process, where different steps may need to be revisited and modified as our project progresses. So that is all from me. The references of the papers we have read have been attached with the slide. Thank you.